Good day everyone, and welcome to our video on limits and differentiation. We hope you enjoy. Let's start by defining rate of change. Rate of change is simply the rate at which something changes over a time interval or period. In mathematical terms, it is the change in the y value over the change in x values, or delta y over delta x. Rate of change can be split into two categories: average rate of change and instantaneous rate of change. In average rate of change, the rate is measured at two distinct points in time, meaning that the time interval is greater than 0. Therefore, this rate of change can be easily calculated without the application of limits. In this example, the table shows how the speed of a car changes at particular moments in time, measured in seconds. Let's say that we wanted to calculate the average rate of change in the speed between 3 and 5 seconds. To do this, we simply take the speeds of the car at these time points, 8 meters and 12 meters per second respectively, and divide it by the difference in time, 5 and 3 seconds. The result is an average rate of change of 2 meters per second across this time. Instantaneous rate of change is when the rate of change is calculated at a particular moment, meaning that the time interval is 0 seconds. Attempting to calculate the instantaneous rate of change at any point using the previous table, we will not be able to receive an answer, as the denominator would be 0 and the operation would be impossible to solve. This is where the concept of limits comes into play. In order to calculate instantaneous rate of change, we do so by taking the derivative of that particular point. In other words, we calculate the slope of the tangent line of the point with which we wish to find the rate of change for. In order to do this, we will use the difference quotient. So, to calculate the rate of change in the speed of the car at 5 seconds, we use the difference quotient and plug in the values of f5 plus h and f5 into the formula and expand. We then simplify this equation until we arrive at the part where h is factorized out, giving us an answer of 2 meters per second. To introduce limits, let's use the function fx equals to x minus 3 over x minus 3. You would suggest that the function will be simplified to 1 as the numerator and denominator are equal. This is however not true. If x is equal to 3, then the resulting expression will be 0 divided by 0, which is an undefined expression in mathematics. So what does this mean for the function itself? It means that when x is equal to 3, the resulting value of the function is undefined. If we take a look at the graph of this function, we can see that there is a hole in it, indicating that the value of fx is undefined when x is equal to 3. However, notice that as x approaches 3, the resulting value of the function approaches 1. Note that we are not finding out the value of the function when x equals 3, rather we are trying to find out what the value of the function converges to as x approaches 3. In short, x approaching 3 is not the same as x equals 3. This is the basic idea of limits. The concept of differentiation involves taking the derivative of a function. The answer that we obtain as the derivative of a function is the slope of the tangent line at any point of x. In other words, it can be said that the derivative of a function can represent the instantaneous rate of change at a point, in relation to limits. Let us consider the function fx equals to 2x squared plus 3x plus 6. By using the difference quotient, we will obtain the derivative, 4x plus 3. What does this expression mean? It means that for any value of x that you wish, the slope of the tangent line or the instantaneous rate of change at that point can be solved by plugging in the x value to 4x plus 3. Let's say that we wanted to find out the slope of the tangent line of the function stated earlier when x is equal to 8. After obtaining the derivative, 4x plus 3, we slot in the x value of 8 into the derivative of the function to get the slope of the tangent line at that particular value, which is 35. Other than finding out the slope of the tangent line at a particular point using derivatives, we can even find the entire equation of the tangent line itself by the use of this formula: y minus y1 is equal to m times x minus x1. In the equation, y1 represents the value of the function of whatever x value that you are investigating. M is the value of the derivative after differentiating the function, and x1 is simply the x value that you are investigating in the problem. Let's take a look at an example. In this problem, we are asked to find the equation of the tangent line of fx equals to 3x squared plus 5x plus 7 when x is equal to 2. First off, we will simply write out the equation as stated earlier. Then, we simplify each required term one by one. In this case, y1 is equal to 29. The derivative of the original function is equal to 6x plus 5 after differentiation, which means m is equal to 17. And of course, x1 is equal to 2. Next, simply plug in the terms that you have just found and isolate y. After some minor calculations, the equation of the tangent line at x equals 2 is found to be 17x minus 5. Notice how this equation is in the form of y equals to mx plus b, as all tangent lines are linear.
Now we will be discussing about the product rule. The product rule is basically a rule used to find the derivative of a product of functions. The formula of the product rule is u prime v plus v prime u. For example, we have this function where u is the first bracket and v is the second bracket. By substituting the derivatives accordingly into the product rule formula and simplifying them would basically give us the derivative itself. Similarly, quotient rule is a method of finding the derivative of a function that is the ratio of two differentiable functions. Its formula is similar to product rule, which is u prime v minus v prime u over v squared. For example, we can use the function 2 over x plus 1, where u is the numerator and v is the denominator. By substituting the derivatives accordingly into the quotient rule formula and with simplifying a little, it would give us the derivative eventually. Next, the chain rule. The chain rule is a rule of differentiating many compositions of functions. It has a formula of dy over dx equals to dy over du times du over dx. It varies depending on the type of question asked. For example, we use function y or fx equals to 3x squared minus 5 to the power of 4 and the derivative needs to be found. Make the value in the bracket equals to u, equate u to y and apply it into the chain rule formula, which gives us the derivative of the function. Thank you for watching this video and have a nice day.